Welcome everyone. In today's video, we're diving deep into the fascinating world of artificial intelligence. Artificial intelligence, often abbreviated as AI, has become a buzzword in recent years, revolutionizing countless industries and shaping the future of technology. But what exactly is AI, and how does it work? In this video, we'll explore the inner workings of AI, unravel its mechanisms, and gain a deeper understanding of this groundbreaking technology. Hey there, tech enthusiasts! I'm your host, and I'm excited to take you on this journey through the intricate workings of artificial intelligence. AI is not just a single technology but a multidisciplinary field that combines various branches of computer science, mathematics, and cognitive science to create intelligent machines capable of performing tasks that typically require human intelligence. Understanding the fundamental concepts and processes behind AI is essential to comprehend its potential applications and appreciate the rapid advancements being made in this field. Let's start with the basics. At its core, AI aims to replicate human intelligence in machines. Human intelligence encompasses a wide range of cognitive abilities, including perception, learning, reasoning, problem-solving, and decision-making. By emulating these cognitive processes, AI systems can exhibit intelligent behavior and perform tasks that were once thought to be exclusive to humans. The fuel that powers AI is data. In today's digital world, an enormous amount of data is generated every second from various sources such as sensors, social media, internet searches, and more. This vast and diverse data serves as the foundation upon which AI algorithms learn and make informed decisions. Whether it's images, text, audio, or structured data, the availability of high-quality and relevant data is crucial for training AI models effectively. However, raw data is rarely in a form that AI systems can readily utilize. It often contains noise, errors, inconsistencies, and irrelevant information. To prepare the data for analysis and model training, a crucial step called data preprocessing is required. During this stage, data is cleaned, transformed, and organized to remove any inconsistencies or noise, ensuring that the data is in a suitable format for further analysis. Now, let's delve into the heart of AI, machine learning. Machine learning is a subset of AI that focuses on enabling machines to learn from data and improve their performance without being explicitly programmed. Instead of relying on explicit instructions, machine learning algorithms learn patterns and relationships from the data they are exposed to. One popular approach to machine learning is supervised learning. In supervised learning, an AI model is provided with labeled examples, which are pairs of input data and their corresponding correct outputs. By analyzing these labeled examples, the AI model learns to generalize and make accurate predictions or classifications on new, unseen data. In contrast to supervised learning, unsupervised learning deals with unlabeled data. In this approach, the AI model explores the data to find hidden patterns or structures without any explicit guidance or pre-existing knowledge of the expected outputs. Unsupervised learning is particularly useful when we want to uncover underlying patterns in data or segment it into meaningful groups. Another fascinating approach to machine learning is reinforcement learning. Reinforcement learning involves an AI agent interacting with an environment and learning from feedback in the form of rewards or penalties. The agent takes actions, observes the consequences, and adjusts its behavior to maximize cumulative rewards over time. Through trial and error, the agent learns optimal strategies and policies for various tasks. Neural networks are a crucial component of modern AI systems, particularly in deep learning. Deep learning is a subfield of machine learning that focuses on training neural networks with multiple layers, mimicking the structure and functioning of the human brain. Neural networks are composed of interconnected nodes, known as neurons, organized in layers. Each neuron takes inputs, performs a computation, and passes the output to the next layer, progressively transforming the data. Training AI models involves adjusting their internal parameters to minimize errors and maximize performance. Optimization algorithms, such as gradient descent, are used to iteratively update the model's parameters based on the training data. This iterative process fine-tunes the model, enabling it to make more accurate predictions or decisions over time. Once an AI model is trained, it can be deployed for inference and decision-making tasks. Inference refers to the process of applying the trained model to new, unseen data to obtain predictions or outputs. The AI model takes the input data, processes it using the learned patterns, and produces the desired output. This capability allows AI to perform a wide range of tasks, such as image classification, speech recognition, natural language processing, and more. And that concludes our in-depth exploration of how artificial intelligence works. We've covered the basics of AI, the importance of data, the pre-processing step, the different types of machine learning, the role of neural networks, training and optimization techniques, and the application of AI in inference and decision-making. Artificial intelligence is a rapidly evolving field with tremendous potential to transform industries and improve our lives. By understanding its inner workings, we can fully grasp the power and possibilities that AI offers. If you found this video informative, don't forget to like, share, and subscribe to our channel. For more exciting content on AI and other cutting-edge technologies. As always, thank you for watching, and stay curious.